All right, today we're diving into one of nature's most incredible paradoxes, the tsunami. We're talking about these silent speedsters of the deep, born in total darkness, that can cross an entire ocean and then show up with just unimaginable force. So how on earth does that happen?
Yeah, that's the big question we're tackling. It's a total mind-bender, right? How can something travel across the vast ocean, basically invisible, and then unleash all of its power in the final few moments? Let's break it down. First things first, where does that name even come from? Well, it's Japanese, and it's a combination of two words. Tsu means harbor, and nami, which means wave. So, harbor wave. And that name is just perfect, because it hints at where all that destructive power is really felt, not way out in the open ocean, but in the confined spaces right up against the coast.
So, where does a monster like this begin its life? Well, it all starts with a massive, sudden jolt, deep down in the ocean, that shoves a colossal amount of water out of the way. Now, usually the culprit is a huge underwater earthquake, where tectonic plates grind against each other. But massive volcanic eruptions from the seafloor or even gigantic underwater landslides can also kick one off. The key, no matter the cause, is always the same. Something has to displace an unbelievable volume of water, and fast.
Okay, so all that water gets shoved aside, and all that energy has to go somewhere. It starts traveling. And this is where that whole silent sprinter idea comes in, because the tsunami begins its race across the ocean.
And what a race it is. Get this, out in the deep ocean, a tsunami can travel at speeds of up to 800 kilometers an hour. That's 500 miles per hour. To put that in perspective, that's the cruising speed of a jet airliner. Just try to wrap your head around that. A wave moving as fast as the plane you'd fly on for vacation.
But here's the wild part. Even though it's blazing along at jet speed, a tsunami way out in the open ocean might only be, say, a meter high, just a few feet. A huge container ship could pass right over it, and the crew would have absolutely no idea. All of that immense energy is hidden, moving beneath the surface through the entire water column.
But that silent sprint can't last forever. As it gets closer to land and leaves the deep water behind, a really dramatic and incredibly dangerous transformation starts to happen. This is it, the critical moment. All of that energy that was spread out across the deep ocean and moving at insane speeds is about to slam into a huge obstacle, the rising seafloor near the coastline. This chart really shows you what's going on. As the water gets shallower, the bottom of the wave starts dragging along the seafloor. That friction basically hits the brakes, and the wave slows way down. But here's the thing about energy. It has to go somewhere. So as the wave slows down, it gets compressed, and all that forward speed gets converted into terrifying height. The invisible ripple becomes a towering wall of water.
And listen, this is something a lot of people get wrong, and it is absolutely crucial to understand. A tsunami isn't just one big wave. It's a wave train, a whole series of waves that can arrive minutes or even hours apart. And very often, the first wave isn't even the biggest one, which is what makes the aftermath so incredibly dangerous.
So with something this powerful, knowing it's coming is everything. I mean, it can literally be the difference between life and death. So how do we spot the signs? Well, we have clues from both nature and from our own technology.
On the natural side, the most famous sign is when the ocean suddenly pulls way back, exposing the seafloor. If you ever see that happen, it's your signal to get to higher ground immediately. No questions asked. Technologically, we have a whole network of seismic sensors that detect the earthquakes in the first place, and then these amazing deep-sea buoys that can actually measure the change in water pressure as a tsunami passes over them, confirming that a threat is on its way.
And the importance of these systems really can't be overstated. The 2004 Indian Ocean tsunami is a tragic and powerful reminder of what's at stake. It traveled across an entire ocean, hitting coastlines thousands of miles away from where it started, and it really drove home just how badly we needed the comprehensive warning systems we have in place today.
So when you step back and think about it, you have this force that's born from a tremor in the Earth's crust. It travels silently at the speed of a jet and then transforms into a coastal giant. It really makes you wonder, what does this incredible, awesome power tell us about the truly dynamic and sometimes violent planet that we all call home?